We've got last few sessions today. The next one is Danh Phan. He's going to be joining us remotely. Here we go, by the power of technology. So Dan's keen on applying data engineering and machine learning tools to solve real-world business problems and is an open source contributor. And today he's going to be talking about building trusted data pipelines with Dagster, dbt, and Duckdb, which are three technologies I'm personally super interested in. So, would you give Dan a warm welcome, please?
Thank you, everyone. Can you hear me? Yes.
Yes, we can.
Thank you for coming to my talk on building 3D trusted data pipelines with Dagster, dbt, and Duckdb. And the 3D here is meant D in Dagster, D in dbt, and D in Duckdb. And sorry, I'm not be able to join the conference face-to-face, and also sorry my voice is not good today. Other than that, today the slide and the code demo is available online on this GitHub link. That later you can get and play around if you have time. And a bit of myself, I'm currently working as a senior data engineer at investment data system team at Hesta. We are a super fund, and I'm also an open source contributor and love camping. Previously, I'm a PhD candidate at Monash University doing machine learning for transport, and had been working as a data analyst, database designers, and web development. And all views and opinions in this talk are my own. All right, so in this talk, first I will talk about the concept of data engineering and why we need trusted data pipelines. And then it will I show a demo and how we can implement this in using the 3D stack. So, as a data engineers, our job is to build pipeline, data pipeline. It is ELT or ETL data pipeline. The general idea here is we move the data from different sources, and then we extract and load it to a place. Whether it is a data like S3 or Azure storage, and then from that we can move it into a data warehouse, and in that we can use different tools to transform our data to from raw data to clean data, and after we have the clean data, we can serve it for the downstream application like building BI dashboard or using for our machine learning model. And when we deployed our data in production, we want to strengthen our data pipeline, right? Because we know that in the future, our data pipeline will likely to be leaked or even break. So that's why we really need a robust and reliable data pipeline. And we have many interesting talks on these topics, on how to build a robust or reliable data pipeline using either Apache Spark. We have a previous talk on PySpark, interesting talk, and there are also other topics on the using Databricks or Shiplab and etc. And this is very interesting talk, and I recommend you to watch it later if you have time. And the lesson learned from this talk is that we need to test our data pipelines, and this is very important. And also, we also need to apply the DevOps practices like code versioning with GitHub, for example, and add just CI/CD, and also we need to add the infrastructure as code like We can use Terraform or CloudFormation for that, and using a container environment, things like Docker, so we have a similar environment for development and for production. And we also have extra things like data lineage or data contract, and hence data contract from the upstream. But in my opinion, the robust data pipeline is not enough. Yes, robust and reliable data we absolutely need that. But in addition to that, we also need to have control our data quality, because at the end, what we building our data pipeline or data warehouse is we building the data and we serve the data for our consumer, for people like data analysts or BI developers and data scientists. So just this data pipeline is, in addition to be robust, it also needs to focus on data quality. So this is an example, like for when we talk about robust pipeline, we talk about engineering focus that we want to strengthen our pipeline to avoid leak or break in the future when we deploy it. While the trusted pipeline, we also need to focus on the data consumer. If data is like water, we want to have a good or clean water or clean data. So if we work as data engineers, often you will hear about the question from other people, from data analysts, from data scientists, about different data quality questions. They might ask you a lot of questions on data quality related things like, is that table compared with the upstream table? Do we have to have this column, or where does data come from, or how recently our data arrived, and or either column of delivery is in expected range, or either summarize statistics for that column in makes sense, etc. And it is really difficult for data engineers to answer the question if we don't have a good data quality testing and measurement in place. So it is really critical to test and measure our data quality. If we need to have trust, we need to test our data quality. So if we look at the modern data stack, I would say, this is an example, but you can see that we will have an ingestion layer using either Python, Spark, or other tool like Airby, Python, and we use this ingestion tool to move the data from different sources here into a data warehouse. And the data warehouse can be maybe Snowflake, Redshift, Databricks, or even Azure Synapse. And when we move the data here, we can use tools like dbt for data transformation, and we can transform the data from the landing or the raw layer to different kind of layer like staging and math layer. And the math layer will be the clean data that can be served for BI tool like Tableau or Power BI, or can be used for data science or machine learning building model in Python or R. And we can also have some orchestration tool like Airflow or Dagster, or some observability like Soda or Monte Carlo here. But the core thing is here, as you can see, that is the ingestion layer, the data warehouse layer, where we have the for computation using different engine here with the tool for data transformation, and then we have some orchestration. So in this workshop, we're going to build a small demo using, for ingestion, we will use Python to move the data from Amazon S3 to a local folder, and then from that we import into a Duckdb database, and then we will use dbt to transform the raw data to staging layer and then to math layer. And inside this one, we will use dbt-utils and dbt-expectations, which is two dbt packages that use for testing our data qualities. And in addition to that, we have the Dagster here for data orchestration. And the good thing for Dagster here is, if you see in the dbt here, we do transformation in SQL, and in ingestion layer, we do PyLine in Python. And then the Dagster can work with both of that to convert both Python PyLine and the transformation PyLine in SQL here to call software asset. And later I will show you that in detail. So what is that? The 3D we have here. The first one is the Duckdb. It's an in-process SQL database management. It is serverless, so if you know SQLite, it will be similar to SQLite. It is serverless, so we don't need to build any kind of server like Progress SQL or MySQL. And that is great because Duckdb is like vectorized column style. So it will be fast and very suitable for analytics workflow. And we can use Duckdb as a small data warehouse in our case, and sit on top of Duckdb is dbt, which we can use for data transformation. And from that, we use different dbt package for control or test our data quality. And we also have Dagster, which is a software-defined asset, which can help us to manage and convert all of this one into a very nice list of data linears and global assets, which I will show you later. So on the testing data quality, from the high levels, we want to test first either between the table. We might need to test the relationship between table. For example, is this customer buy product, so or the relationship between the table. Or we can test if the raw tables with the clean table if they have the same shape or have relationship with that. Within one table, we can test the row count, column axis, etc. And at column level, we can test it depend on different kind of data on that column. If it is text, we can test the pattern of that. If it's categorical text data, we can test if it belongs to a list of accepted value. If it's numeric data, we can test if the mean, the max, median, or the outlier as well. And if we have the date in the table, we can test the recency, the range of that as well. In addition to that, we can have generic test if the column is not null or is unique or not. So we can use the different dbt packet to test all of this kind of things in our data pipelines. So the first basic one in dbt is they ship with the 4 genetic tests: unique, not null, accepted value, and relations. So here is one example how to write the test. So the model here, the name here is the order table, and in here is this one we have column name order ID, and it need to be unique and not null for that primary key. And another column is called status, and the status here for the orders, it should be in one of 4 value here. And the third column here is customer ID. It will have relation to the other table of customer and in the ID column. So this is one example of the 4 generic tests in dbt. But if we want to test more complex things, we need other packet like dbt-utils and dbt-expectation. So to do that, in dbt we just need to include the packet into a packet.xaml file, and then we install it using the dbt-deps command, and then we run the test using dbt-test. And for the dbt-utils, this is a packet from the dbt team, and they ship with more different tests. Like we can have a generic test like equal row count, equality, oscillate one or constant, and we can also have the non-null proportion, which is quite useful. And we can also have different relations and unit combination tests here. You can find more information on the link I put here, and also in the reference later as well. For dbt-expectation, this is the idea is we are similar to a great expectation packet in Python, and they divide it into different group of tests. Like for table shape, we can test if the column exists in the table. We can test the column count, row count, etc. And for the missing value, unique value, we can also test. They have various tests here as well. For if it is a numeric column, we can test the value of the column is between something as well. And for the string or the text column, we can test if it's matching some kind of pattern. And they also have some basic testing on distribution, like if the column value within n standard deviation, which can be used to test the outliers in the numeric column as well. So there is also a lot more information in the documentation, and I recommend you to look at it at a later time. So what we're going to build? We're going to build this PyLite where we extract the data from S3. So the data here, we have three tables: the payment, the order, and the customer. And we use Python to extract that one and input into a raw table into Duckdb. And from that, we will use dbt to transform that three table into a staging layer. And from that staging layer, we transform it into the math layer, which is the orders table and the customers table at the end. And this is how it looks in the data asset in Dagster. Thus, we can view both SQL PyLite and Python PyLite together. And this is just a closer view I will show you later in the demo as well. And you can see that this part is from dbt, so it have an icon as dbt here. All right, so now is time for the demo. So I will switch to the code. So this code is available on GitHub, and from that you can find the link to the slide as well. And just a reminder that is the PyLite we're gonna build using injection Python, get the source into Duckdb and transform it, and then using Dagster for orchestration. So on the left here, if you see that we have two main folders, one is for dbt and one for Dagster. And first, let's go to dbt. So the data, we have three tables: raw payment, raw order, and raw customer. After we download it, it will be inside this one. Just have a quick look on this three table. This one is the customer with ID, first name, last name. We have the order for that. The customer with user ID and then order ID, order date. And then we have the payment for this order. And inside the dbt project, we have define the profile, which is defined in the profile here. As you can see, it will be here, and then it will link to the Duckdb database, which is actually one file, this file, which is this file, JavaShop DB Duckdb. And later we can also have different target for production, and we can replace it with other bigger data warehouse like Snowflake or Redshift. And as mentioned before, for the testing our data quality, we install a couple of packages like dbt-utils and dbt-expectations in the package.yaml. And let's go into the model. So we have the staging, where we have that three staging table here and our model. And in the schema, we can define the testing for our quality test. Like for example, customer ID need to be unique and not null. The customer ID in the staging customer table, sorry. And like the status for that staging order table, it should be in one of these five value: place, ship, completed, etc. here. Similar in the math here, we can also control our data quality. For example, here I add another tag for the first name of the customer table. It needs to be not null, so at least 98%. So 98% of that first name column of the customer table it should be not null. And five others tests here, like here I want to check if that customer table here with a similar shape as the staging customer. So this one have this similar row count. And also want to check if that table have 7 column. So now if we want to test it, we just in dbt we just run dbt test, and it will run all the tests in our just edify in our schema here. And you can see that we have 18 tests here and it passed. So for example, if I change it on from 7 to 10 column, and if I run dbt test and I select the customer table, it will test only run the test only for just customer table, and you can see we have 6 tests, and we have one error here, which is the count equal 10 here, which actually 7, right? So if I change it back to 7, and I run dbt test customer again, it should succeed for the 6th test. Yep. And another thing here is the good thing in dbt, we can see the generate our documentation as well. And after you do generate the documentation, we can serve the doc. By the way, all this command I already put it in the README here as well. So if you see that it's on the browser, let's go. I think.
Hey Dan. Hey Dan, can you hear me?
If you click on this link, it will show us the documentation, and it will show the table with information here as well. Like Another thing is it can also help us to, I think if we click on this one and click on the graph, we can show the pipeline here. But as you can see, the pipeline here only the SQL in dbt, and we cannot see the upstream pipeline using Python, right? So that's why we add Dagster. So let's back to the second folder. Here is Dagster dbt-example, and in here, let me go to cd Dagster, and in here we define the software assets, and the main code is here. But before that, let me run the Dagster, which will run the Dagster server. And inside the Dagster here, we can define the asset, and we have two main types, right? The first one is the dbt, which we can load it by references. It load asset from dbt project, and we can specify the path to the folder of dbt, which is this one. Which is this one, the dbt example shop. And then after that, Dagster will get the metadata from dbt example shop project and it put it as an asset. Another part here is we have the Python, which is we load Python from S3 and import into Duckdb, which is defined in the raw data here. And in this one, you can see that we have just a simple code that extract the raw data. For example, if it is raw data order here, we read the data from S3 and then we save it in here. And then after that, we will create the raw order folder and insert it into the Duckdb file. And in Dagster, we just need to add a decorator called assets, and it will load that and consider all the pipeline as asset. So after we run the Dagster, we can view it in the website here. I think. And if we click on global asset, you can see that we have all our data pipeline here with both Python and SQL pipeline in dbt. And we can also materialize all this table, which is actually we run all the pipeline in this graph, and then we can see the run as well. But also here, if we click on different tables, they are start to materializing, and we can see all the detail and metadata and other information here as well. And they also have the running, which for different steps that we have. And that's it. And while we're waiting for this one to finish, I think it will need a couple of minutes for it to finish. Let's back to the slide. So I just showed you just one example, a way to implement our data pipeline with both Python and SQL pipeline, and add different tests using dbt-utils and dbt-expectations to control the data quality. But at the end, building trust is your journey, and we will need to have a good roadmap. And especially the most important, in my opinion, is very strong leadership with the right data strategy. And that, as previous speaker also mentioned about the data contract, and we need to buy in different data stakeholder and data consumer. And in the technical perspective, we also need to have well-designed data schema, and we need to control the data quality from upstream on the way in the data warehouse or data lake, and on downstream as well. And a couple of references that I use for the talk, and thank you very much for that. And by the way, our team are hiring for data engineer position. Thank you, and let's come back to.
Thank you so much, Dan.
More here to see if the Dagster already finished. So if it finished, it will be battle right here. Yeah.
Live demo. That's great. Thank you so much.
Yeah.
These are all tools I've been really intrigued to know about.
Yeah, thank you. Yeah.
dbt especially has been one that I haven't managed to look into as much as I'd like to. So thank you so much for that. That was great. Obviously, we're out of time now, so we don't have time for questions. But the next talk will be at in 10 minutes, at 4:10. Thanks a lot, Dan. We'll hopefully see you in person sometime soon.
Everyone.
See ya.